transform of periodic functions. Laplace transform of periodic functions. So first of all, we want to know what is called a periodic function. What is called a periodic function? What is called a periodic function? So the definition of periodic function is a function f of x is said to be a periodic function if and only if f of x plus p equal to f of x is true for some value of p and every value of x. The least positive value of p for which f of x plus p equal to f of x, or for which this equation becomes true for every value of x, will be called as the period of the function. Is called the period of the function f of x. So on seeing the definition, you know two things. When f of x plus p equal to f of x, the function is called periodic function. The least positive value satisfying this f of x plus p equal to f of x will give you the period p. So for example, I am going to tell you few examples. The examples are very simple and you may know about it very well. Suppose if I am taking sin x. Suppose if I am taking f of x equal to sin x or cos x or tan x, etc., any trigonometric term. So I am going to check what is about f of x plus 2 pi. What is about f of x plus 2 pi? When f of x equal to sin x. When f of x equal to sin x, what about f of x plus 2i? That is also sin x. What about f of x plus 4 pi? It is also sin x. So, and it will go on like this, and this is true for cos x, tan x, and for all the trigonometric terms you will have some period 2 pi, 4 pi, etc. So here by our observation we found that f of x equal to sin x is also equal to f of x plus 2 pi, which is also equal to f of x plus 4 pi. So here we are having f of x equal to f of x plus 2 pi and f of x equal to f of x plus 4 pi and so on, when f of x equal to sin x, when f of x equal to sin x. So we can call sin x as a periodic function, Okay, here the period p is a positive constant. See, the least positive value, they have mentioned it as positive. So here the p should be greater than 0. The p should be greater than 0 because f of x plus 0 will not change other than f of x. F of x plus 0 is equal to f of x, but there is no meaning of having this 0. So it should be greater than 0. Okay, if I am considering this 0 means, then definitely 0 will be the period, but I am not going to consider this. So this 2 pi will be the period because the least positive value is f of x plus 2 pi is giving f of x, f of x plus 4 pi is also giving f of x. The least positive value of p giving this value is 2 pi. So sin x is a periodic function with period 2 pi, sin x is a periodic function with period 2 pi. So this is the definition of periodic function, and we have provided an example to identify how the periodic function will be, okay, and what will be the period. So I hope you understand the concept of periodic function. Now we are moving on to the next topic, Laplace transformation of periodic function. Laplace transformation of periodic function. So can you take it down? Laplace transformation of periodic function. Laplace transformation of periodic function. So generally we know that Laplace transform of a function f of t will be integral 0 to infinity e power of minus st f of t dt. So this is the Laplace transform of any function. Suppose if this f of t is periodic function, if this f of t is periodic function, what will happen? This f of t, suppose this f of t is periodic function, what will happen to L of f of t? What will happen to L of f of t? What will happen to L of f of t? That is what we are going to discuss here. The Laplace transformation of, can you take it down? The Laplace transformation of the periodic function is given by L of f of t. L of f of t equal to 1 by 1 minus e power minus ps integral 0 to p e power of minus st f of t dt. F of t dt, where this f of t equal to f of t plus p, f of t or f of t plus p equal to f of t, because this is a periodic function. In the same way, p greater than 0 is a period of f of t. Okay, what p? The least positive, the least p, least value of p greater than 0 is called pillar of t. So I have once again given you a definition where explaining the formula here. For the formula itself is enough. L of f of t equal to 1 by 1 minus e power minus ps integral 0 to p e power minus st f of t dt. So I hope you are clear with the formula. Now we are moving on to our first problem. So before going to our next problem, I want you to know some important formulas, and the formulas are relating the trigonometric terms with exponential term, and the formulas are follows. The following formulas are relating the trigonometric terms, especially the hyperbolic functions of trigonometric ratios with that of exponential terms. The first thing is sin hx. Sin hx equal to e power x minus e power minus x divided by 2. Cos hx equal to e power x plus e power minus x by 2, and tan hx equal to, we know that sin h divided by cos h will be tan h, so we will have e power x minus e power minus x divided by e power x plus e power minus x. So these three formulas are important in many occasions. Now we are going to see our first problem under Laplace transform of periodic function. So take down the problem. Now the problem is find the Laplace transform of the rectangular wave given by f of t equal to 1 minus 1. 1 is for the value of t lying between 0 to b, and minus 1 is for the value of t lying between b to 2b. So for this we are going to see the solution. So solution, we are given f of t as 1 for 0 less than t less than b, and minus 1 for b less than t less than 2b. We know that the Laplace transform of f of t is given by 1 by 1 minus e power minus ps integral integral 0 to p integer to p e power of minus st f of t dt. So here we are having the function f of t is a periodic function with period to be in the interval 0 comma 2b. In the interval 0 comma 2b. See, the function is always 1. It is not going to change if I add t plus any value that is less than b, and this value will not going to change if I add any value between b to 2b. Okay, if I add f of t plus 1 which is less than b, means the value is 1 itself. If I add f of t plus any value which is greater than b means and less than 2b means its value is minus 1 itself. For any value satisfying the condition, we will give the same value for the function. So f of t is periodic for the corresponding intervals. The total interval is given by 0 to 2b. Okay, the total interval is for 0 to b, and for b to 2b we are having two different values, but the function is traveling from 0 to 2b in the open interval. Since we are not having equal sign in front of the 0, b behind b, in front of b and behind 2b for that less than symbol, so these will give you the open interval 0 comma 2b. So for the interval open 0 comma 2b, the period will be 2b. The period will be 2b. You have to subtract the final interval minus the initial interval. So you will have the period 0 to b. Or if you have minus b comma b means then also the period will be 2b, because the total period will be b minus of, that is final limit of the open interval minus initial limit, that is b minus of minus b, that is equal to 2b. Then also the period will be 2b. Okay, if you are having minus b to 0 and 0 to plus b means then also the period will be 2b. Okay, that you have to always keep in mind. Okay, now we shall substitute everything here. L of f of t equal to 1 by 1 minus e power of minus 2b. Yes, since p equal to 2b, integral 0 to 2b e power of minus st f of t dt. Now our f of t is split into two different values for the two different set of open intervals. So we shall utilize that. That is equal to now we shall split the function accordingly as given in the question. So we will have 1 by 1 minus e power of minus 2bs integral 0 to b e power of minus st. For 0 to b we are having the value of f of t as 1 into dt plus integral b to 2b e power of minus st. The value of f of t is minus 1 into dt. So we will have 1 by 1 minus e power of minus 2bs integral 0 to b e power of minus st dt. This minus 1 is constant, so we can write it as b2 do to be e power of minus st dt, and this is again equal to 1 by 1 minus e power of minus 2bs. On integrating it, we will have e power of minus st by minus s, and it will have the lower limit as 0, upper limit as b, minus it will give you the same integrand, that is e power of minus st divided by minus s. The limits are 2b as the upper limit and b as the lower limit. Now we shall substitute the limits. So we will have 1 divided by 1 minus e power of minus 2bs, e power of minus bs minus e power 0 is 1 divided by minus s minus we will have e power of minus 2bs minus e power of minus bs whole divided by minus s. Now it will become 1 divided by 1 minus e power of minus 2bs into e power of minus bs minus 1, then minus e power of, okay, we shall write everything into one common denominator. E power of minus bs minus 1 minus e power of minus 2bs, then plus e power minus bs whole divided by minus s. So in the denominator we are having minus s, we shall write it as plus s. So it will become 1 minus e power of minus bs. I want to write this minus in the denominator as plus s, so I am multiplying the entire, I am taking this minus to the numerator, so minus 1 will become plus 1, plus e power minus bs will become minus e power minus bs, and this is minus e power minus bs, then e power minus 2bs whole divided by s. Now we shall have the following thing: 1 divided by, I am writing this as 1 minus e power of minus bs. What is this 2bs actually? So you have to know one thing: a power x the whole square is a power x into 2. A power, you know that is a power m whole power n equal to a power mn. In the same way it will become a power 2x. In this place we are having e power of 2x, that is we will have e power x the whole square. So what is x? X is 2b, x is minus 2b here, sorry, x is minus b here. So we will have 1 minus e power minus bs the whole square. Okay, 1 minus e power minus bs the whole square, and here you will have 1. This can be written as 1 minus 2 e power minus bs plus e power minus bs the whole square whole divided by s. So this can be again written as 1 divided by 1 minus, this is a square minus b square. So you can write it as a plus b into a minus b. So 1 plus e power minus bs into 1 minus e power minus bs into, this can be written as a plus b whole square, because a minus b whole square, because a square minus 2ab plus b square. Here a equal to 1, b equal to e power minus bs. So 1 minus e power minus bs the whole square divided by s. Okay, so it can be written as 1 divided by 1 plus e power minus bs into 1 minus e power minus bs into 1 minus e power minus bs into 1 minus e power minus bs whole divided by s. So here the common terms in the numerator and denominator will get cancelled. So these two terms will get cancelled. So we will have 1 by s into 1 minus e power minus bs divided by 1 plus e power minus bs. So this is our L of f of t now. But the problem is not yet completed. We can further simplify this term in such a way that 1 by s into, I am writing this as 1 minus e power minus bs by 2, again minus bs by 2 whole divided by 1 plus e power minus bs by 2 minus bs by 2. Okay, so a power m plus n is equal to a power m into a power n. A power m plus n equal to a power m into a power n is what the next concept we are going to use. Okay, and another thing is, the idea we have applied here is, we can write x equal to x by 2 plus x by 2. Am I right? So here this minus bs is like x. I have treated this minus bs as x by 2 plus x by 2. That is why minus bs by 2 minus bs by 2. So now it is in the form of a power m plus n. So I can write it as a power m into a power n. So this will become 1 by s into 1 minus e power minus bs by 2 into e power minus bs by 2 divided by 1 plus e power minus bs by 2 into e power minus bs by 2. Why? I am telling you the reason, because I want to convert the entire terms from exponential form to trigonometric form. That is the idea. Okay, so for that I want the form related to hyperbolic form. So I am using all these extra works. Okay, that is the reason. There is no other reason behind this. So I had written this bs as bs by 2 plus bs by 2. Since we are having minus in the prefix, it will become minus bs by 2 minus bs by 2 in both numerator and denominator. and this is like a power m plus n, so I am writing it as a power m into a power n. Now this e power of, see, x power of minus m can be written as 1 by x power m, am I right? So I am going to write this like that. So that is 1 by s into 1 minus e power minus bs by 2 divided by e power bs by 2 whole divided by 1 plus e power minus bs by 2 divided by e power bs by 2. Okay, now this can be further written as 1 by s into e power of bs by 2 minus e power minus bs by 2 divided by e power bs by 2 plus e power bs by 2. So this is looking like 1 by s of, I am writing it more clearly here, e power bs by 2 minus e power minus bs by 2 divided by e power bs by 2 plus e power of minus bs. It is, yes, okay, e power minus, I think this is minus, okay, this is e power minus bs by 2. So the denominator, when you divide, the common denominator will get cancelled, so we get only this, and we know that this is nothing but tan h, e power of x minus e power minus x divided by e power x plus e power of minus x, okay, equal to tan hx. So x is bs by 2, x is bs by 2, 1 by s tan h bs by 2. So this is our required L of f of t. This is our required L of f of t. I hope you all understood the problem, and this is very important problem under periodic function. There are many important problems under this section. All the problems are important part B questions, so you have to watch it clearly, watch it carefully, and you have to practice it more number of times to get a clear idea about how to solve this function. So thank you all for watching this video. Thank you all once again.